So first we need to define a polygon. A polygon is a closed figure with a finite number of sides. Okay, what does the word finite mean? What does the word finite mean? Specific number, okay? It doesn't go on forever. Infinite is the opposite of finite, right? So we have a specific number of sides, right? Not an infinite number of sides. And it's a closed figure with these sides, okay? The next thing we have to realize is that those sides cannot cross. They can't intersect, okay? They only intersect at the endpoints. They can't intersect in the middle or in somewhere within the sides. So, if we look at this guy, we have to decide if it's a polygon or not. What do you think? Yes, in fact, you probably know a specific name for it. What kind of polygon is this? It's a trapezoid. It's a specialized quadrilateral, okay? So yes, this is a polygon, okay? Next one, is this a polygon? No, why not? They intersect somewhere other than the endpoints, okay? How about this one? Is this a polygon? Yes, what kind of polygon is it? It's a quadrilateral, and unlike this convex quadrilateral, it is concave, okay? So that's a concave quadrilateral, okay? And then finally, is this a polygon? No. Exactly. Does not have a finite number of sides. Okay? All right. So, polygons can be classified by their number of sides. And we spent some time yesterday talking about those, so it should go fairly quickly. Okay? So if it has 3 sides, it's a 4 sides. Quadrilateral is the most general version. A square is an example of a quadrilateral, but quadrilateral is the most general version. 5 sides, 6 sides, 7 sides. Okay. Like hexagon, but we change one letter, and it's, or 2 letters. It's a heptagon. Okay, we replace one with 2. Okay. Now, some people call it septagon. It depends on whether you're in the Greek or the Roman version, but our book uses the heptagon. Okay, 8 sides, octagon. 9, it's a nonagon. 10 is decagon. And then 11 actually does have a name. It's an undecagon. But we won't worry about it. We're not going to quiz you over that or test you over it. Okay? 12, dodecagon. Okay? And if we get beyond that, to the polygons that don't have formal names, we can call it an n-gon, like a 16-gon or a 20-gon. Okay? Or a 9-gon. Okay? Make sense? Right. So next, we want to talk about that interior angle sum theorem. Okay? If we want the sum of the total sum of the interior angles of a polygon, what do we do? First, we have to figure out how many sides. So how many sides does this first one have? 4. It's a quadrilateral. And since it's a quadrilateral, how many triangles can we make from one vertex? Total of 2. Draw one angle or one segment connecting, and now we have 2 triangles. Since we have 2 triangles, one triangle has how many degrees? So 2 triangles is going to have, yep, 360 degrees. Okay? How many sides? So it's a pentagon. So how many triangles would it have? 3. So we're going to take 3 times 180, and we get 540. That's our sum of our interior angles. Okay? How many sides? 6. How many triangles? 4 triangles. So we're going to take 4 times 180, and we get 720 degrees total for all of those angles inside. Make sense? Okay, so we came up with a formal definition. We said that if we want to know how many degrees there are total inside of a polygon, we take n minus 2, the number of sides, minus 2 times 180, or 180 times that number of sides minus 2. Number of sides minus 2 tells us how many triangles we get. Okay? Question on this one? All right. So the next one says then, let's talk about exterior angles. Okay? So your exterior angles form a linear pair with an interior angle. What does linear pair mean? Forms a line. Okay? How many degrees in a line? 180. Okay? So when we're looking for a linear pair or an exterior angle, we're going to take 180 minus the interior angle. Okay? So those are the exterior angles of a rectangle. Here are the exterior angles of a triangle. We just extend the sides out. Okay? And what do we know about the exterior angles of a triangle or a decagon or a dodecagon? The sum of them is how many degrees? 360, because they collapse and form a circle, and a circle has 360 degrees. We make the sides really small. Okay, make sense? So they add up to 360. Doesn't matter whether it's a regular polygon or whether it's an irregular polygon. Doesn't matter how many sides you have. The exterior